Before I move on to the questions, I want you to go through the concepts once again. So what exactly is the center? Whenever we are talking about the center, we are basically looking at the mean, median and occasionally mode. These two are very important. When we talk about spread, we are basically looking at the range and sometimes standard deviation. And when we talk about the shape, we are basically talking about whether the graph is symmetrical, is it unimodal, is it bimodal, skewed right or skewed left. I have talked about these measures of central tendency in detail in my earlier videos. I want to look at the shape of the graphs in this video. Let's have a look. This is the first graph that you should be aware of, and it looks like this. Consider the following data set. We have got these values. This data set can be represented by the following histogram. Each interval has width 1 and each value is located in the middle of an interval. Now this graph is called a symmetrical graph. Why do we say it is a symmetrical graph? Because the values on the right and the values on the left are a mirror image of each other. Look at the first value and the last value. You will see they are a mirror image of each other. Similarly, look at the second value and the second last value. They are also a mirror image of each other, and so on. It's also called a unimodal because it has got one peak. A graph which has one peak only is called unimodal. If a graph has two peaks, then it's called bimodal. If a graph has three peaks, then it's called trimodal, and so on. This graph is also called a bell-shaped graph. Why? Because apparently it resembles a bell. So if I draw a bell like this, to me it looks like an inverted quadratic equation, but I hope you understand the analogy. Lastly and most importantly, the measures of central tendency. Whenever you are looking at a symmetrical graph which is unimodal, the mean, median and mode will be equal. So if you look at this data, please calculate the mean, the median and the mode. You will see all the values will come out to be 7. This is the most important thing that you need to remember for a symmetrical graph. Now let's have a look at this graph. The histogram for the dataset is not symmetrical. The right hand side seems chopped off compared to the left side. Our distribution of this type is called skewed to the left because it is pulled out to the left. Now, what does skewness mean? The first thing to understand is this question. So whenever you have got an histogram or a bar chart or even a line, and if more of the values are concentrated on one side of the graph, it can be left side or the right side, that's called skewness. Like in this histogram, more of the values are concentrated on the right side. Hence, it is called skewed left. It's the opposite terminology that you need to use. The easiest way to remember this is through an analogy. Let's say you are taking a slide, and if you're going to the left, it's called skewed left. That means more of the data will be on the right. That's something you need to understand. Secondly, you see data is not symmetrical. I think it's pretty obvious when more of the values are concentrated on either side of the graph, then you cannot have a symmetrical data. Thirdly, and most importantly, the measures of central tendency, mean, median, and mode. This is something that you need to understand. So if you calculate, you take out the mean, that is just add up all these values and divide by the total number of values, you will get 6.3. Median is the middle value, that is 6.5, and mode, all of us can see, that is 7. So whenever you have a graph that is skewed left, mean will be less than the median and that will be less than the mode. This is the most important thing that you need to remember for a skewed left histogram. Lastly, we have got this graph which is basically skewed right. How do we know that? Let's take a slide. You see, you're going from left to right. That means it is skewed right. Secondly, data is not symmetrical. You can see more of the values are concentrated on the left side of the graph. Hence, it can't be symmetrical. Now, the most important thing, the measures of central tendency. We need to look at the mean, median, and mode. So this is the data set that we are looking at. Please pause the video and take out the mean, median, and mode yourself. You will see that mean equals 7.7. Median is 7.5, the middle value, and the mode is 7. That is something we can clearly see. So in this graph, mean is the greatest, Then we have the median, and lastly we have got the mode. You can clearly see 7.7 is greater than 7.5, which is greater than 7. These are some of the things that you should immediately understand whenever you have got a graph which is skewed either to the right or to the left. Now that we have looked at the various shapes of graphs, it's time to do some questions. A police officer recorded the travel speeds in miles per hour of traffic on a major arterial road. The histogram below shows the number of vehicles driving at each speed. Which statement best compares the mean and the median of the data? You can clearly see that it's a symmetrical graph and it is unimodal as well. It has got one peak only, and when the graph is symmetrical, when it has one peak, the mean, mode and the median are all equal. So let's evaluate the option choices. There is no mean value for this data. This is completely wrong. The mean is greater than the median. No. The median is greater than the mean. Again, this is wrong because we know the data is symmetrical. Mean and median are approximately equal. This is our answer. There you go. Next question. Data was taken on carpooling in Tallahassee, Florida. For each person's daily commute, the number of people in the car was recorded. Okay. The results are summarized in the bar graph below. What is the median number of people in the car? Okay, this time there's no comparison, you have to calculate the median. But you can clearly see this graph is skewed right. Okay, next thing, what's the formula for the median? That is n plus 1 divided by 2. We have studied this earlier, where n is the total number of items that we have in a list. But this is a group data. So how do we calculate n? The x-axis basically tells us the variable most of the times. Please remember this. The x-axis gives us the variable, whereas the y-axis basically gives us the total frequency. So if I make a table of x and frequency, let's see what do we get. The number 1 is occurring how many times? Let's say this is 82. Number 1 is occurring 82 times. Number 2 is occurring, let's say, 8 times. 8 times. Number 3 is occurring, let's say, 2 times, and number 4 is occurring 1 time. So this is our total frequency. Add these up and let's see what do we get. 82 plus 8 is 90, 92, 93. This is the total frequency that we have. Now let's apply the formula. So n is the total number of items, that is 93. 93 plus 1 divided by 2 is basically 47. So the 47th value will give us the median. Where does the 47th value lie? It basically lies here, and 47th value corresponds to number 1. So we have got 1 till the 82nd value. So you see, if I ask you where does the 42nd value lie, it's obviously 1. Where does the 20th value lie? It is 1. Where does the 50th value lie? It is 1. Where does the 80th value lie? It is 1. So the median is 1. This is the answer that you will put in the grid. Next question. In the dot plot below, the length of the coastline of each country in South America is shown in thousands of kilometers. Okay. Rounded to the nearest 1000 kilometers. According to the dot plot, what is the mean length of coastline in thousands of kilometers? So mean is basically sum over total number. We already know this formula and the formula never changes. But we have a dot plot. How can we calculate the sum and the total number from this dot plot? Let's convert this dot plot into a table. And for that, we need our variable x and we need the frequency. So let's first evaluate both these terms. What is x in this scenario? It is the length of coastline. This represents our x, and the frequency are these dots. That's something you need to identify as soon as you read the question. So x is basically 0. And how many times do we have 0 here? 1, 2, 3, 4, 5, 6. We have got 0 6 times. Now what does that tell us? It tells us that there are 6 countries which have got 0 kilometer of coastline. Very simple. 1 is occurring how many times? 2 times. Then we have got 2. That is also occurring 2 times. Then we have got 3 also occurring 2 times. 4 is occurring 0 times. 5 is occurring one time, 6 is also occurring one time, 7 is also occurring one time, and 8 is 0. So this is basically our frequency. You add up the frequencies, what do you get? You have 6 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 13, 14, 15. So the total frequency is 15. Now in this scenario, whenever you have a table, what's the formula? The formula is summation fx over summation f. You know what to do. Multiply these numbers so we get the sum and then divide by the total frequency, that is 15. Let's do the math and let's see what do we get. So if I multiply these, I will get 6 into 0, 6 into 0 plus 1 into 2. I'm just writing the number because it will save space here. 1 into 2 is 2, plus 2 into 2 is 4, plus 3 into 2 is 6, plus 4 into 0 is 0, plus 5 into 1 is 5, plus 6, plus 7 divided by the total frequency, that is 15. Now do the basic math and see what do you get. You will get 0 here, 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 5 is 17, 17 plus 13 is 30. 30 divided by 15, our mean is 2. That's our answer, 2000 kilometers basically, but you will put this in the grid.